This is the Building Automation Monthly Podcast with Phil Zito, episode 109. Hey folks, Phil Zito here, and welcome to the Building Automation Monthly Podcast, where every week I help you learn building automation systems and enhance your knowledge of the building automation industry. In this week's episode, I'm going to be starting on another three-part series. This one is going to be focused in on control sequences. And I got a lot of really good feedback on the past three-part series. A lot of good positive feedback around going deeper into the subject matter. And just in general, folks were saying, hey, man, we really liked this stuff. So what I'm going to be doing is kind of taking more deeper dives and spending more time on topics. So you're probably going to see a lot more of these multi-part episodes coming up. So what are control sequences? I would say in my opinion, but I don't even think it's an opinion. I would say it's a fact, even though I don't have really any facts to back it up with, but I would say understanding control sequences is quite possibly one of the most important things you can learn in the building automation industry, because if you want to program, you need to understand control sequences. If you want to sell something, you need to understand control sequences. If you want to engineer things, you need to understand control sequences. I mean, the examples could go on and on. But what I find is that a lot of folks, especially a lot of folks who are entering the industry, but surprisingly, even a lot of folks who have been in the industry for quite a while, they just don't understand what control sequences are. And that's a shame, because having a good understanding of control sequences can really set you apart from everyone else, and it can make your life a lot easier. I mean, like, a lot easier. I would say one of the best things I ever did in my career early on was reading the Honeywell Gray Manual, which, I mean, the beginning of it is pretty, okay, let's be honest, the whole thing is really freaking dry. I mean, it's pretty boring. But at the same time, it still is, it's just jam-packed with sequences, and it goes into some really, really good depth of what sequences are. And because of that understanding, and then because of an early mentor that I had when I was going through my career, when I was just starting, he made me go and actually diagram out sequences. I've told you all, at least I think I've told you all this story before. This is kind of when you've done almost 110 episodes, you kind of forget what stories you've told. But I think I've told you all about how he would have me sit down with a piece of paper and a control stencil and draw out exactly how everything was going to operate. It drove me insane. It was so irritating. But that kind of knowledge really translated well. It reminds me when I was a little kid, my dad, when I would come home every day through high school, my dad would go and he'd have a article from the Wall Street Journal sitting out, and I had to write a one-page summary of that article. And it was this, you're in high school, all you want to do is chase girls and play video games. At least that was my high school experience, that and wrestling. So, I mean, that was it. That's all I did. But instead, I would have the joy of writing one-page article summaries every freaking day. It was no fun. But I learned how to get really good about writing things, and it's carried over and helped me a lot in life. Well, the same with understanding control sequences. So I think at this point you can really appreciate that control sequences, they're just very important. All right. So then again, what are control sequences? We started on this path, and I think I've hammered home why they're so important, but what are control sequences? What are they? Well, control sequences exist to tell you how equipment should operate. And I'll link to a couple control sequences as we move throughout this series, because later on in this series, we're really going to unpack some control sequences. We're going to dive through them. But control sequences exist to tell you a couple things. And the four main things that you're looking for is the start and stop conditions of the equipment you're controlling. What is turning on the equipment? And more importantly, what is turning off the equipment? In order to run equipment, you need to know when to go and turn it on. Because if you can't turn the equipment on, it doesn't do any good, right? I mean, you can have this really cool air handling unit or chiller just kind of sitting there, and if it's not on, nothing's going to happen. So that's the first thing. It's got to turn equipment on and off. But then it's also going to tell you how to control the equipment. So when's the equipment in cooling mode? When's the equipment in heating mode? When's it in dehumidification? When's it in free cooling? When's it in humidification mode? When do these modes trigger? And that is a really important thing for you to understand. Now, what do I mean by when do these modes trigger? Well, here's the deal. You've got to understand not only what do these control modes do. So let's take cooling, for example. You have free cooling, you have mechanical cooling, you have dehumidification-based cooling, where you're essentially subcooling the air to remove moisture from it, causing the moisture to condense and just kind of rain down the coil into a condensate pan and run out of the unit. So you got a couple different types of cooling. So first off, when does each of those modes trigger? Well, the cooling for dehumidification may be based on return air humidity. The free cooling may be based on outdoor air temperature. The mechanical cooling may be based on outdoor air temperature and space temperature or discharge air temperature. You've got so many variables, and I find that a lot of folks just want turn-on cooling when they initially get into programming or they get into design or they're in troubleshooting. They go and they see the DX coil on or they see the chilled water coil open. And they're, oh, I'm in cooling mode. Well, what kind of cooling mode are you in? What kind of cooling mode are you in? And a lot of folks will not go beyond that. That's called systems thinking, right? It's looking at the entire system, and we covered this in earlier episodes. It's looking at the entire system and understanding what the interrelationships are. And so you need to understand not only what is the system controlling. Do I have DX? Do I have chilled water? Do I have reheat? Do I have gas-fired reheat? Do I have electric heat, preheat, whatever? But then you need to understand how it's done and what causes this system to operate. Okay, so we've got turning on the equipment. What enable modes are there? And then we've got going and controlling the different variables, the different I guess you'd call them devices inside the system. After that, so after that, then you have what puts the equipment in alarm or failure or safety condition. I remember very early on in my career, I had a professor, not really a professor, a trainer, and he said, the first thing you should do is program the alarms, because that way you never miss them. And I listened, and I did that dutifully, and in my opinion, that's completely wrong. And that's, in my opinion, completely wrong, because think about it this way, right? I have heating output, or I have a fan command, and I pre-program all the alarms and safeties. But then I add some control logic afterwards. There's a high likelihood that by adding that control logic, and I'm talking to programmers out here, by adding that control logic after going and creating those safeties, you're going to actually potentially code around those safeties. So I don't want to say opinion, again, because I've said that so many times. My experience says that you want to do alarms and failure conditions last. You want to get your start-stop conditions programmed. You want to get your control modes programmed. And that's essentially what we're talking about, right? What turns the equipment on off, that's a start-stop mode. What controls the equipment, that's control modes. And then after doing those two things, then and only then will you go and actually program in your alarm, your failure conditions, and your safety conditions. Because those are going to override everything else. Okay, you with me so far? You seeing kind of the three parts right now? Now, the fourth part of this is going to be the auxiliary control sequence dependencies, okay? So what does that mouthful of information mean? What that means is any system that's dependent on this system to run, but this system is not dependent on those systems running. Does that make sense? So for example, maybe you have some exhaust fans, and whenever the air handler is on, the exhaust fans run. But the air handler does not need those exhaust fans to run. It can run without them. But the exhaust fans need the air handlers to run because otherwise they're not going to have the air that they need to exhaust. You see kind of very basic example there, but those are auxiliary control sequences. Now, if you think about a typical air handling unit, and you think about it with these 4 steps in mind, and we're just going to really do a flyover here. In the next 2 episodes, we're going to go a lot deeper into this. But if you think about that in mind, right? Basic air handler, supply fan, variable speed drive, discharge air temp control, reheat valve, cooling valve, mixed air damper setup with a low limit on the mixed air temp. Well, your on-off conditions are going to be enabling the air handler to turn on. That's it, right? You turn the air handler on. When do you turn it on? Typically an occupancy schedule. Then you've got your control modes. So you've got a discharge air pressure control mode since you've got a supply fan with a VFD on it. So that's one control loop. We've talked about control loops in previous episodes. Then you've got a cooling loop that's discharge air temperature driven. You've got a reheat loop that can as well be discharge air temperature driven. You've got a mixed air temp sensor with a low limit sensor that can be used to drive free cooling to control. Maybe you do something like mixed air temp is 10 degrees less than return air temp set point as long as it's above the low limit. Something like that, right? And then economizer control. You do free cooling and maybe you could do CO2 control to reset the minimum of the outdoor air damper. So you do a high select. But I mean, that's it. You're sitting there and you're thinking through all those things. Those are your control modes. And then you got safeties. You got a low limit safety. You got a high pressure safety. You got a low pressure safety. You might have a smoke alarm safety. But you see these safeties come after the on modes and after the control modes. And maybe downstream you have VAV units that are dependent on the air handlers being on in order for them to control to their airflow set points. So you got to see how all these interdependencies work and how these steps of a sequence works. Now, the reality is that most sequences you're going to get handed, this is just the way it is, are not going to follow this format. They're going to be in whatever the heck format the engineer got from the controls contractor. Because let's be real with one another. A good portion, I want to say most, I so want to say most, but hey, I'm not going to do it. A good portion of consulting engineers will just take whatever control spec the controls contractor gives them, and they will use that thing until the cows come home. They will just keep using it. I remember working on a high school that the consulting engineer was known for his rooftop unit specs. Man, this guy could create a 2.5 ton to 5 ton rooftop spec, and it was solid. Until he came to this high school, and he wanted to put 300 rooftop units on the high school. And we were like, what? And the owner was like, what? And the mechanical and the general were also like, what? It did not make any sense. Like, why are we not using a VAV air handler setup and a central utility plant? I mean, like normal people do. Well, we don't design that. So yours truly, myself, I got to write the control sequence for the central plant. Mind you, I am not a professional engineer. I am not licensed to create control sequences. But nonetheless, I was doing it because this consulting engineer did not know how to create a central plant sequence of operations. And that's kind of the world a lot of you are going to live in, is that you're going to be asked to interpret something that may say, turn the air on and control the unit to 55 degrees. And literally that may be the sequence you get for an air handling unit. And you're going to have to interpret everything else. So how do you do that? Or maybe you get a control sequence that is all over the place. You've got the fan command, and then you've got an alarm, and then you've got a cooling sequence, and then you got something else kind of placed in the middle of it, and it's like reading something written by a 6-year-old. It just kind of drifts all over the place, makes no sense, and has no logical structure. Well, to do that, you're going to use a strategy that I like to call chunking. And essentially what you're doing is you're going to print out the sequence, you're going to take a highlighter, and this is something you can use today. This is something that as you go to the job site or as you're reviewing a project and you've got a control sequence in front of you, I really encourage you to do this today. So you take, 3 different highlighters. I'm not going to tell you what color to use, but just pick a color for your on-off conditions, pick a color for your control modes, and pick a color for your safeties. Then what you do is you highlight the control modes, the on-off modes, and the safeties according to their color. Then you go and reorder those. So you get your on-off modes, those go at the front, your control modes, those go at the middle, your safeties, those go at the end. And here's what you're doing. You're accomplishing 3 things. 1, you're making sure that you don't miss anything, because it'll become readily apparent when you have all these things broken out in their categories, whether you're missing a control mode or an enable mode or a safety mode. It's a lot harder to pick that stuff out when it's in the sequence, when it's in that kind of mess of words. Rather, when it's all broken out into these neat categories, it becomes readily apparent. I don't know if any of you have been using Google Maps lately, but at least the time of me recording this in the first week of April of 2018, they've got this thing on Google Maps. Now, do not stop the podcast and go look for this. Continue the podcast. But on Google Maps, if you go there, they have a Where's Waldo pop-up, and then you can click on it, and you can actually spend, and I may not have done this, that's may not be why I know about this, that cannot be proven, but you can actually spend hours going through maps looking for Waldo on the Google Maps feature, because they built that in there somehow. But here's the thing, that's what it's like when you have a unorganized control sequence. It's like, where's Waldo? You're looking for these things, these parts in this giant multi-page control sequence. Versus when you actually go and you segment this out and you chunk it out. Now you've you've made things easier to read, right? 2, you've made things a lot easier for your programmer. So now you've made it very easy for that programmer to follow. Okay, so that programmer can simply code, because as I'm about to go into in just a second, there's a coding process that is supported by this sequence structure. Okay, so we've got our sequence structure of turning equipment on and off, equipment that controls it, how is it done, and the alarming and failure conditions and the auxiliary conditions. That's our sequence structure that we want to strive to. We get there by chunking using that highlighter strategy. That allows us to 1, know where everything's at. 2, allows our programmers to write code. And 3, allows our service operators to troubleshoot what's going on a lot easier, because they can just simply follow the checklist. Is it on? Well, yeah. Okay, if it's on, what control mode is it in? Oh, okay. Well, then, is it in a failure mode? Oh, it is in a failure mode. Oh, okay. I can't tell you how many times I've had folks troubleshooting air handlers only to have mixed air low temp sensors tripped or high static fan sensors tripped, and them just be spending time. I don't get it. I put the fan in hand and it's just not turning on. Well, it's because the high static safety's tripped and it's a manual reset and you got to push the button to reset it. I mean, I say that kind of tongue-in-cheek and sarcastically, but any one of you who's been in the field for any amount of time will know that happens so often. All right, so that is why we want to do this chunking strategy. That's why we want to go about and we want to organize our sequences into chunks. Now, once you've done this, I hinted at this, right, with it being making our programmer be able to go and really understand things. But here's the deal. So you've went through a sequence, you've went and reorganized a sequence, and now you've chunked out that sequence. Now what's going on is we are looking at what are called the 5 steps of programming. Okay? So for any of you who have done programming, this will sound fairly familiar. But for those of you who are new to BAS, maybe you're starting to understand programming, then you're definitely going to want to listen. And as well as those of you who are in sales, I don't want you to get caught up with the fact that this is programming, okay? Because what you can do, a lot of salespeople reach out to me and they say, Phil, how do I know what parts and pieces I have on a specific system so that I can estimate the project? And this is the same advice that I would give potential programmers is what I'm going to give you. Because doing this, you're going to know exactly what devices are physically there. So the first thing you want to do whenever you are taking a sequence is you want to look for the inputs and outputs. So once you've chunked everything, right, you're going to have an input and output highlighter. One color for inputs, one color for outputs. So this will not be on the text that you just highlighted. Because remember, we're highlighting, and then once we've highlighted in the previous step, once we've highlighted our start, stop modes, our control modes, and our safeties, we've reorganized everything. So now we have a fully organized sequence of operations that's organized from the start, stop conditions, the control modes, and the safeties. So it's clean, it's got no highlighting on it. Now what you're going to do is you're going to highlight the inputs and outputs. Okay, so you're going to highlight those. Those are going to be your physical inputs and outputs. And that is the first thing that you're looking for. Once you have those, then you can add those to the program. You always want to add those to the program first. Now, for a lot of the salespeople who are listening to this, this is the step you stop at. This is all you got to do. You just highlight your inputs and outputs. You'll physically know what's included. If you've got a supply fan with a VFD, well, what do you got to have, right? Supply fan status, supply fan command, supply fan output. Boom, done. Now you know what you got. Potentially, and then you find out, are we carrying the VFD or is the mechanical carrying the VFD? Or if you are the mechanical and you're doing controls, well, then you know the answer to that. But that's it. For salespeople, done. I mean, that's all you do. And I don't understand why folks... Actually, I do understand why folks struggle so much with this, because people aren't being taught this. People are being taught these crazy things of, go look up the manufacturer's documentation and figure out what's there and read their terminal blocks. Why don't you just read the sequence and figure out how things are supposed to start and stop? One, you'll be a lot more aware of how things actually control, but two, you'll get the exact inputs and outputs you need. Okay, so you got the inputs and outputs you need. You add those to your program. Then you write your start and stop logic. Okay, so now you just write your fan logic, you write your pump logic, you write your anything that is a Boolean commanded object. Anything that's on, off, true, false, start, stop, that's Boolean. 2 states, right? It's either on or it's off. 1 or 0. Then, after you've done that, step 3 is to add your control states. So control states are analog. These are 0 to 100%, 0 to 50%, 0 to 4, whatever. This is your staging, this is your damper control, this is your valve control, this is your speed control. These are control states. So you've got your inputs and outputs, you've got your on-off modes, and now you add your control states. From here, we then go into implementing our safeties and shutdowns. Remember, just like I mentioned before, we want to go and implement our safeties and shutdowns at the end of our sequences. So we've added our inputs and outputs, we've written our start stop logic, we've added our control states, and we've implemented our safeties and shutdowns. And for those of you who are like, that's great, I don't know how to code any of this, I'd recommend checking out my programming guide that I'll have it linked to in this episode's show notes. And it's a pretty good guide on just all the different logic blocks and kind of some control strategies, things like that. So you do that. And then finally, you do your auxiliary control. This is exhaust fans. This is linking to VAV box, anything you got to do. And there you have it. That is how you go about taking a control sequence and turning it into programming. So what I want us to do, what we are going to do on the next two episodes, is that we're going to go and we're going to actually pick through some control sequences. I'm going to read through control sequences, pause, and kind of tell you how I interpret them. And trust me, that is not going to be near as boring as it sounds, because when I first thought about that, I was like, man, that is going to be freaking boring. I'm going to read a control sequence out loud, and then folks are going to hear me read it out loud, and I'm going to provide my thoughts and commentary. It's like someone reading the newspaper and providing their commentary on today's article says, no, it's not going to be like that. We're actually going to go and explore through these sequences and really start to understand the logic and thought process that is going on. So we're going to do that for two very common sequences, for a rooftop unit and a air-cooled chiller sequence, which conveniently are two of the sequences I use in my upcoming programming course to teach folks how to program building automation systems. So that is what you're going to expect in the next two episodes. So what I want you all to do today, I'm actually going to give you some homework in this episode. I want you to take a sequence that you are working with right now, and I want you to go and I want you to use the process you learned today. You remember the process, right? How to chunk things out, reorganize, and structure. I want you to do that today. And then what I want you to do is to go post your sequence in the comments section of this podcast episode. So that can be found at buildingautomationmonthly.com/109. And one person who posts in there, one person at random will be picked, and they'll get a free license to my Control Sequences Fundamentals course. It's a $1,300 course, and you will get access to it. So I'll pick one person, and this will be going on this entire week. So you'll have up to April 9th to take your sequence, whatever sequence you want, go through the chunking process, reorganize it in the structure I've laid out in this episode, post it. I mean, literally, we're talking 20 minutes of your time, and you can earn yourself a $1,300 course that is getting amazing reviews by my students. This course will change the life of your career. And for those of you who just want to purchase the course, which I highly encourage you to do, out of all of my courses so far, this one is one that I'm saying every BAS professional needs to go through this course. It is absolutely career changing. So I will have a link to that course for you to pick up that course. But like I said, everything will be available at buildingautomationmonthly.com/109. And that challenge will go on until April 9th. So you have April 9th of 2018. If you're listening to this in the future, then, hey, sorry you didn't listen live and you missed it. That sucks. But, hey, we'll have more of these in the future. That being said, thank you so much for listening to today's episode. I really appreciate you being here. This is actually going to be a pretty awesome series. I know you are going to learn a ton as we go through these next two, part 2 and part 3 of this series, where we dive into a sequence and we just rip apart. Now, I did heavy squats this morning at my CrossFit workout, so I'm all like testosteroned up. I'm like, rah, break everything. No, but probably gonna drive my wife batshit crazy today. But anywho, that's neither here nor there. But for those of you who are in this series, man, it's going to be a ton of fun. We're really going to just have some fun with these control sequences, and we're really going to pick these things apart. So I can't wait to talk to you next week in part 2 of this 3-part series. Thanks a ton for being here. Do not forget to go and use your organizational structure and reorganize the sequence and post it to the comments, because you have the opportunity to win a $1,300 course by simply doing 15 minutes worth of work. So thanks a ton. I will talk to you all in the next episode. Take care.